Okay, what we're going to do in this vodcast is talk about this concept of molecular formulas. You should have already watched the vodcast on empirical formulas, and if you haven't, you definitely want to go back and watch that because I'm going to use some concepts in this video from that video. I am using a new program, so there's going to be some glitches here and there as I get used to it. So let's go advance our slide. I'm going to get a pen here. And I'm going to go with black. Okay, so we already talked about what empirical formulas are, and we said that those are the simplest whole number ratio of atoms or elements in a compound. So for example, our empirical formula might be CH1, which doesn't tell us how many carbons there are or hydrogens in the compound. It just tells us that there's a 1-to-1 ratio of carbons and hydrogens in a particular compound. So for example, we might have a compound with C3H3 as the formula. In other words, there's actually 3 carbons and 3 hydrogens, which really wouldn't be a compound, but just take my word for it. So that would be the actual compound, but if you reduced these subscripts to their lowest whole number ratio, we would have a 1-to-1 ratio. And that's what we call the empirical formula. And you should know that already. Alright, well, just the same way we have a possibility of a compound with 3 hydrogens and 3 carbons, down here our example shows a compound with the same empirical formula, just with a ratio, with a number of carbons being 6 and the number of hydrogens being 6. So our molecular formula is going to tell us the actual formula of the compound, or in other words, the actual number of each element within that compound. Okay, let's do some examples, and again, I'm going to use the technique that we learned about in empirical formulas to do most of this problem. So if you've already watched the video on empirical formulas, you're going to know most of this. Alright, we have our percentages like we did with the empirical formulas. So we're going to take those percentages, 49.3, and if you remember, we're going to write those percentages as grams. So we have 49.3 grams of carbon, 6.9 grams of hydrogen, and 43.8 grams of oxygen. Now remember, we're not using the diatomic form of hydrogen and oxygen because we're trying to write an actual compound, so these subscripts will be dictated by the formula of the compound. Remember, diatomics are only used when the element is by itself. But since they're part of a compound, we use the elemental form. In other words, 1 hydrogen, 1 oxygen. Okay, enough of that. The next step we did was we converted to moles. So I'm going to use the molar mass, 12 grams per mole for carbon. That's supposed to be a time sign. Well, now it just looks like a scribble. 1 gram per mole for hydrogen, and 16 grams per mole for oxygen. Let's do the math here. We get 4.1 moles for carbon. We will get 6.9 moles for hydrogen, and we will get 2.74 moles for oxygen. If you remember, the next step is to divide all 3 of these by the smallest of the 3. So we're going to divide them all by 2.74, 2.74, and 2.74. When we do that math, we're going to get 1.5. I believe that's 2.5. It is. And of course that's going to be 1. Okay, so again, from our empirical formula lesson, we know we're going to have to multiply by a factor of 2. So we're going to multiply them all by a factor of 2 so we have whole numbers to work with. So we will have 3, 5, and 2. So now we know that our empirical formula for this compound is going to be C3H5O2. Alright, all of that should be review from the last vodcast, so let's talk about the molecular formula part of this process. You're going to be given the molar mass of the actual compound, and in this case it's 146 grams per mole. So I am just going to write that down here for right now. Since the molecular formula is going to be some factor ratio of these subscripts, in other words it might be C9H15O6 or something like that, the molar mass of this formula is going to be some ratio of that formula. So to figure out what that ratio is, what we're going to do is add up the molar mass of the empirical formula. So 3 times 12 plus 5 times 1 plus 2 times 16. When we do that, we get 73. So what we're going to do is we're going to take our molar mass from our molecular formula, our molar mass from our empirical formula, and we're going to divide the empirical formula into the molar mass of the molecular formula. We'll get 2 there, so that tells us that everything in our empirical formula must be multiplied by 2. So we'll multiply 2 times 3 to give us C6, 2 times 5 to give us H10, and 2 times 2 to give us O4. So our molecular formula is going to be C6H10O4. And if you added up the molar mass of that, I'm sure you realize this, you should get a value of 146. Okay, let's do another problem. Again, let's take our percentages and write them in grams. 48.6 grams of carbon, 8.1 grams of hydrogen, and 43.2 grams of oxygen. Let's divide by the molar mass. 12 grams per mole, 1 gram per mole, and 16 grams per mole. Let's do that math. We get 4.05. I don't know if the 0.5 is necessary, but we'll leave it there. And we're going to, whoops, that's a heck of an equals sign. And we're going to get 2.7. We're going to divide everything by 2.7, 2.7, and 2.7, so we get 1.5, a nice round number of 3, and 1. So as you can see, we're going to multiply by a factor of 2, and if you multiply 1 by a factor of 2, you have to multiply them all. Alright. So as you can see, our empirical formula will be C3H6O2. So let's add up the molar mass of that. I'll write it here. 3 times 12 plus 6 times 1 plus 2 times 16. And we get 74 again. Alright, so let's take our given. So anyway, we're going to divide our known molar mass by the empirical formula molar mass, and we get 4. So we're going to take 4 times 3 is 12, 4 times 6 is 24, I believe, and 4 times 2 is 8. And again, if you add up the molar mass of that, whoops, you'll get 296. Alright, that's the end of that video. You're certainly welcome to email questions to hannonandchemistry@gmail.com, and obviously if you're a student of mine, you're going to ask those questions in class. And that is it.